The pixelation limit. There's a smallest possible unit of space. It's called the Planck length, roughly 1.6 times 10 to the negative 35th meters. Smaller than that? Physics stops working. That's not just tiny. That's suspicious. Because in a truly analog universe, there shouldn't be a minimum size. Space should divide forever, infinite resolution. Instead, it bottoms out, like a screen that won't zoom in past a certain point, not because of your eyes, but because there's nothing left to load. That's exactly how digital simulations work. The resolution isn't infinite. It's just high enough to fool you. So what does that change? It breaks the assumption that reality is smooth, continuous, and infinitely explorable, and it opens up something way more interesting. If there's a minimum unit of space, there's a chance you're living inside something that was built, not born, and builders always leave patterns, which means, if you study the seams, you might not find meaning, but you might find the manual. Number 9. The observer effect. At the quantum level, particles don't behave until someone's watching. Literally, electrons act like a wave, existing in multiple states, until you measure them. Then they choose one path and lock into place. It's called the observer effect. And it's not a theory. It's been replicated over and over. That shouldn't be possible. Observation shouldn't change physical outcomes. But in quantum mechanics, it does. So how do you explain it? Some physicists say it's because the universe doesn't render itself fully, unless attention forces it to, exactly how a video game only generates what the player sees. Which brings us here, all that stuff people laugh at. You create your reality. Your focus shapes your world. Life is a mirror. They might have gotten the mechanics wrong, but they got the principle right, because if attention collapses probability, then where you look might actually dictate what becomes real. Not spiritually, mechanically. That's not magic. That's user interface. Number 8. Mathematical compression. There's something off about how tidy the universe is. The most complex phenomena, motion, mass, gravity, even time, can all be expressed with ridiculously small equations. E equals mc squared, the Schrödinger equation, Einstein's field equations, not pages of code, not chaos, just compressed elegance. And in nature, that's rare, because randomness produces mess, entropy. But this looks authored. Programmers do this all the time. Instead of manually scripting every outcome, they write one line that generates them all. The code isn't a list, it's a formula, one that scales infinitely, without ever changing its core logic. So if reality itself is running on elegant math, that doesn't prove a simulation. But it does change the strategy. Because in systems like this, brute force never works. You don't fight the system, you reverse engineer it. Start looking for patterns. Stop assuming chaos, because the moment you speak the system's native language, it starts responding. Not emotionally, just efficiently. Number 7. Cosmic censorship. Black holes don't just warp space, they erase it. At their center is something called a singularity, a point where gravity becomes infinite, time breaks down, and the math flat out fails. But here's the part that gets weird. You can't see it. Not because it's far away, but because physics won't let you. There's a boundary, the event horizon, and once anything crosses it, it's gone. No data, no light, no information ever escapes. It's not just hidden, it's off limits. Physicists call this cosmic censorship, the idea that the universe deliberately hides its own breakdowns. And if that sounds like a glitch patch, that's because it might be. Simulations don't crash, they sandbox the problem. They isolate the edge cases so the user never sees the seams. So if black holes are unseeable, unreachable, unmeasurable, then they're not just extreme objects, they're firewalls, which begs the question, if the universe is blocking access to its source code, maybe it's not because you're not smart enough, maybe you're just logged in as a guest. Number 6. Probabilistic reality. In classical physics, reality is cause and effect, predictable, clean, logical, but quantum mechanics disagrees. Hard. At the smallest level, particles don't behave deterministically. They exist in probabilities, not this will happen, but this might happen, with a certain likelihood. And until something interacts with them, they remain in a suspended maybe state. This isn't uncertainty from ignorance, it's baked into the system, which should be terrifying. Unless it's not an accident. Because in video game design, probability isn't chaos, it's a feature. Randomness creates dynamic outcomes, replay value, emergent behavior. So maybe you're not in a broken reality. Maybe you're in a sandboxed one. A world designed to respond to how you move, not just what you know. Where possibilities don't collapse until you act. This doesn't mean everything happens for a reason. It means nothing happens until there's a reason, and most people never create one. Number 5. Processing efficiency. Ever notice how the moon is always facing the same side toward Earth? Or how stars don't twinkle in space? Or how, for some reason, the universe seems to get blurry the farther out we look? Here's what that might mean. Not everything is being rendered at once. In a game, the system only generates what the player needs. The more active the area, the more resources it gets. Background elements stay low res until you interact with them. It's called dynamic rendering, and it's efficient. Now ask yourself, why haven't we found life elsewhere yet? Why does deep space look like a painting? Why is it that the most unprovable theories are the most resource-intensive? Maybe it's not empty out there. Maybe it's just idle. And here's the twist. If the simulation renders based on activity, then your actions matter more than your beliefs. Your movement, your curiosity, your input. They might not change reality, but they might decide how much of it you even get access to. If you never ask, the system doesn't answer. And if you stay passive, the game stays on pause. Number 4. Memory glitches. Memory isn't a recording. It's a reconstruction. Every time you remember something, your brain rebuilds it and subtly rewrites it. This is scientifically confirmed. The phenomenon is called reconsolidation. Each recall introduces distortions, filling gaps, altering details, sometimes inventing entire scenes. And it gets weirder. Large groups of people sometimes misremember the same thing. That's called the Mandela effect. Like misremembering whether the Monopoly man had a monocle or what the Berenstain Bears were actually called. Mainstream psychology says it's just false memory, but simulation theorists point to something else. When multiple users remember different versions of a shared event, you're either dealing with human error or a patch update that didn't sync cleanly. Either way, it breaks one assumption, that your memories are real. So what do you do with that? You stop treating memory as proof, and you start seeing it as rendered content, fluid, rewritable, and less reliable than you were told. That doesn't make your past fake. It just means the system lets you believe whatever story keeps you logged in. Number 3. Consciousness loops. You think you're aware because you have thoughts, but science has never explained how those thoughts come from neurons. The brain processes input, electricity, chemistry, light, heat. But the you that watches it all happen? That sense of self? No one can find it. It's called the hard problem of consciousness. The idea that subjective experience can't be explained by physical processes alone. Simulation theory offers something wild. What if consciousness isn't inside the system? What if it's what's interfacing with it? Your sense of self, your awareness, your attention. Not byproducts of the brain, but an external signal using the brain as a receiver. Think of it like this. The character thinks they're alive, but the player is somewhere else entirely. And here's where that breaks the script. If your consciousness isn't in your body, then you're not stuck in here. You're linked in, which means fear, pain, shame, limitation. They're just signals on a dashboard. Unpleasant? Sure, but they're not you. They're just what the interface uses to keep you invested in the game. Number 2. Artificial time. Time feels fixed. A second is a second. A minute is a minute. But that's only because you're standing still. Einstein proved that time stretches and compresses depending on gravity and speed. Two people moving at different velocities will actually experience time differently, not just perceive it, live it. That's not a metaphor. That's physics. So if time isn't universal, and it's not absolute, what is it? One answer: a variable runtime clock. In simulated environments, time doesn't move on its own. It runs based on cycles, inputs, and rendering requirements. And sometimes, to preserve processing power, it slows down or speeds up behind the scenes. So if time in the real world isn't consistent, maybe it's not a law of nature. Maybe it's a function, a setting, a local rule. And what does that mean for you? Stop assuming you're late. Stop assuming there's not enough, because if time bends to context, maybe urgency is an illusion designed to keep you clicking. You're not running out of time, you're being told you are. Number 1, the anthropic trap. Here's the final glitch. The universe looks perfectly tuned to support life. Not just any life, your life. The physical constants, gravity, the strong nuclear force, dark energy, are balanced so precisely that even tiny changes would make reality uninhabitable. Physicists call this the fine-tuning problem. It's like finding a computer that just happens to have the exact specs you need, to the decimal point, and assuming it built itself by accident. So what's the usual explanation? Oh, there must be infinite universes and we just live in the lucky one. That's not logic, that's coping. Simulation theory takes a different route. Maybe the reason this universe supports life is because it was programmed to, which flips everything. You're not insignificant. You're not random. You're not a blip in a meaningless cosmic accident. You are part of the function, your awareness, your decisions, your inputs. They're not the side effects of the system. They're the purpose of it. And if that's even partially true, then maybe the glitch was never in the simulation. Maybe it's in the way we've been taught to ignore it.